So today we are going to study about Kadanes algorithm. It is basically used to find the maximum sub-array sum. So here we look at the question. Given an integer array nums, find the continuous sub-array containing at least one digit which has the largest sum and return it. So basically here the array given is -2, 1, -3, 4, -1, 2, 1, -5, 4. So we need to find the sub array which has the largest continuous sum. Here we see that -4 plus -1 plus 2 plus 1 would give us a sum of 6, which cannot be obtained from any other combination. If we see for -2 plus 1 -3, here we get the sum of -4. So this isn't the largest sum. So basically we have to code it for all the corner cases as well as for the normal array where all the sums are positive. So here we start coding, and basically we take two variable. Current sum is equal to, we take it to be the first array's number and the largest sum, max sum. So it is also equal to nums of 0. Now we'll start iterating from the first digit. I is equal to 1, I is less than nums dot size minus 1, nums of size, then I plus plus. What we are going to do here is we'll first check if the current sum is greater than the max sum. Then we'll update the max sum. In that situation, is greater than max sum, then max sum would be equal to current sum, right? We'll run through a array. First let's code the problem. Then what happens is we'll check if the current sum is less than 0, so we'll update it to 0, so that in the case where we are going towards more negative side, we first reduce the value to 0 and then we subtract more negative value. So now what we'll do is current sum plus equal to nums of I. Here we'll complete the iteration, and then if we'll again check for the last situation, if current sum is greater than max sum, then current sum is greater than max sum. Right, and then we'll return the maximum sum value. Now we'll try run through the given array. What happens in different cases? Case 1 be this. So presently our current sum is equal to -2 and max sum is also -2, right? So we start iterating from the first index, that is 1. Here we check if the current sum is greater than the max sum, then it is not, because -2 is not greater than -2. Then we do not update the maximum sum. If we check if current sum is less than 0, that is -2. Yes, it is less than 0. So now what we do is current sum is updated value 0, right? And then now what we do is we add the current element, right? Current sum plus equal to number 5. So here in the first iteration we update to current sum is equal to 1. Cool. Then in the second iteration, when I is equal to 2, sorry, when I is equal to 2, we check if the current sum is greater than max sum. It is so max sum here becomes 2. We check if current sum is less than 0. It is not so, because it's already 1. Sorry, here it's 1. So we add the current element, that is -3, to current sum. So now current sum becomes -2, right? -2. In the next iteration where I is equal to 3, max sum is greater than is not less than the current sum, that is 1 is not less than -2, so we do not update the max sum. Here max sum is again 1, and then we check if the current sum is less than -2, so yes it is, so we update the current sum equal to 2, and then we add the current element, that is 4. So now the current sum becomes 4. Right. Then for the next iteration I is equal to 4, we check if the current sum is greater than the max sum. Yes it is, so max sum becomes 4 now. Cool. So if we again check if current sum is less than 0. No it isn't, so we again add the current element, that is -1, so current sum now becomes 3. Then in the next iteration we check for the inequality it is not, so then we add the element again, 2, that is 2, so the current sum becomes equal to 5. Right. I is equal to 6, we check if max sum is greater than current sum, is less than current sum. Yes it is, so max sum becomes equal to 5, and then we add the current digit, that is 1, so the current sums become equal to 6. Then for the iteration 7, we check if the current sum is greater than max sum, it is so max sum becomes 6. So here we've got a final answer, that is sum equal to 6, but we continue to iterate, and then what happens is I is equal to 8, the current element, that is -5, is added to the current sum, and the current sum now becomes 1. And the next iteration we check, we do not update the max sum value, and then 4 is added to the current sum becomes 5 again. So now we are out of the iteration here, and then we move to this part. We again check if the current sum is greater than the maximum for here is 6, and then we check if 5 is greater than 6. No it is not, so we return the max sum here. Now we test the code for its correctness. The test case is running fine. We'll check some other cases where the array is entirely negative values. Also -1 should come. It is giving us correct answers for these cases. And here we have right solution. Hope you have had a good understanding of Kadanes algorithm. Thank you.